and welcome to today's lesson. In the part 1 of this video, we had defined increasing functions, decreasing functions, interval of increase and decrease, as well as critical values and critical points. So I suggest that you watch that video first before coming back to this one. In today's lesson, we wish to take 2 examples to illustrate these concepts. Example 1. Find the critical point of the function f of x equal x squared minus 8x minus 9. Determine the interval of increase/decrease and sketch its graph on the domain on the interval minus infinity to infinity. We proceed as follows. The function given to us is f of x equal to x squared minus 8x minus 9. The next thing we do is to differentiate the function f prime of x, and that gives us 2x minus 8. The first part says we should find the critical point, and to find a critical point we must first find the critical values. And how do we get the critical values? If you recall from the last video, the critical values are gotten when f prime of x is equal to 0. That is to say, when the first derivative of the function is equal to 0. Now, f prime of x in this case is 2x minus 8. So if we set 2x minus 8 equal to 0, what do we get? We get that x is equal to what? 4. Hence, x equal to 4 is the only critical value, is the only critical value. So the function f of x equal to x squared minus 8x minus 9 has just one critical value at the point x equal to 4. The next part says we should determine the interval of increase/decrease of the function. So what do? We sketch our real axis and locate the critical value x equal to 4. So x equal to 4, let us choose this point as x equal to 4. Now we are asked to evaluate this on the interval negative infinity to infinity. So on the interval negative infinity up to infinity. Now when we do this partitions the interval into 2 parts. The first part is negative infinity to the point 4. And the second part is from 4 to to infinity. So we want to determine if the function increases in this interval or decreases in that interval, as well as check if the function increases in the second interval or decreases in that interval. Before then, we're asked already here to find a critical point, and what we have here is the critical value alone. So to get a critical point, we substitute the value of x equal to 4 into the function. So we have f of 4 is equal to 4 squared minus 8 times 4 minus 9. And this gives us 16 minus 32 minus 9. And that is minus 25. So the critical value of this function is x equal to 4, and the critical point of the function is what? A point is an ordered pair. Is 4, minus 25. So it means that at this point on the graph of this function given to us, the slope will change either from negative to positive or from positive to negative. We shall find out what happens there exactly very soon. So back to the issue of interval of increase and decrease. Now we have 2 intervals, between minus infinity and infinity. The first one being minus infinity and 4, open interval, and the second one being 4 and infinity, another open interval. Now to check what happens in this interval, we pick arbitrary points, any arbitrary point on both intervals, and investigate what happens there. For the first interval, I pick the value x equal to 0. Since x equal to 0 is in this open interval. Now, you put in the value of x equal to 0 into the first derivative of the function, since you want to know what happens, at that point. So f prime of 0 gives us what? 2 times 0, 2 times 0 minus 8. And that is what? Negative 8. So negative 8 is less than 0. What do we conclude from here? So we observe that at this point, x equal to 0 on this interval, the slope is negative. So we conclude that on this interval, the slope at all points is negative. And if the slope is negative on an interval, what does it make that interval? It makes that interval what? A decreasing interval. It makes it what? A decreasing what? Interval. Since in this interval, the slope of all points is less than 0. We do the same for the second interval. So we pick x equal to 5 in the second interval, 4 to infinity. And if we do this, f prime of 5 will give us what? Will give us 2. And 2 is positive. So what do we conclude? We conclude that the function f of x is an increasing function on this second interval. So f of x is a decreasing function on the first interval. Meanwhile, f of x is an increasing function on the second what? Interval. It is now time to sketch the graph of this function to see how it looks like. We have the following information. The critical point is 4 and minus 25, and the first interval is a decreasing interval, second interval, increasing interval. So how do we sketch the graph? So we draw our axis this way. This is the origin 0. So the critical value was at x equal to 4. So this is x equal to 4 critical value. And the y value is negative what? 25. And that is the downside here. Negative 25 is somewhere here. Let's call it negative 25. So we have negative infinity to what? To infinity. So the critical point is 4, minus 25. So 4 is this point here. That's the point. 4, minus what? 25. So this is the point where the slope will change either from negative to positive or from positive to what? Negative. So the first interval from negative infinity to 4, what happens? That interval is a decreasing interval. So between this point and this point, the interval is this way, decreasing interval. And between 4 and infinity, the interval is an increasing interval. That means the graph goes this way. So that is just a sketch of the graph of the function in question. We now take the second example. So example 2, here the function is f of x equal to x cubed minus 6x squared plus 9x plus 3. And we're asked to find the critical point, the interval of increase and decrease, and we should also sketch the graph on the interval minus infinity to infinity. So again, we differentiate. So f prime of x gives us 3x squared minus 12x plus 9. The next thing we have to do is to find the critical numbers or the critical values, so that with the critical values we can find the critical point. To find the critical values, what do? We set the first derivative to 0. And that gives us this. We can simplify this further to get x squared minus 4x plus 3 equal to 0. And what we have here is a quadratic equation in x. So if we solve this equation, we get two values of x. We get that x is equal to 1 or x is equal to 3. So in this problem, we have two critical values. The first one is x equal to 1 and the second one is x equal to 3. With these critical values, we can now get our critical points as follows. For the critical point at x equal to 1, we substitute the value of 1 into the function. So f of 1 gives us 7. And that means that the critical point there is 1, 7, because x is 1 and the y value is 7. The critical point at x equal to 3 is f of 3, which gives us 3. So the critical point there is 3, 3. When we sketch the graph of this function, we shall see exactly how it looks. Next, we want to investigate the interval of increase/decrease of the function. So we have our x-axis this way. We have two critical numbers here. The first is x equal to 1, and the second is x equal to what? 3. And our domain is minus infinity to infinity, minus infinity to infinity. This now divides or partitions our domain into 4 intervals or 4 sub-intervals. The first one being minus infinity to 1, second one being 1 to 3, the third one being what? 3 to and 3 to infinity. So it divides into 3 sub-intervals, 1, 2, and 3. The next thing we want to do now is to investigate if the function is an increasing one in this interval or decreasing, as well as the other 2 intervals. So like we did before, we pick any value within these intervals and investigate what the sign is. In the first interval, minus infinity and 1, I pick x equal to 0 in the interval, and f prime of 0 gives me 9, and 9 is bigger than 0. Therefore, in this interval, the function is an increasing function. In the second interval, I pick x equal to 2, and f prime of 2 gives me minus 3, and minus 3 is less than 0. We conclude that in the second interval, the function is a decreasing one. In the third interval, I pick x equal to 4, and f prime of 4 gives me 9, and that is bigger than 0. So in the third interval again, the function is an increasing one. With this information, as well as the critical point, we are now well equipped to sketch the graph of the function as follows. We now have the following information: critical point 1, 7 and 3, 3. And for the intervals, increasing function in this interval, decreasing on this interval, and increasing on the third interval. So we sketch our axis without wasting much time. So this is our x-axis, our 0 point. So the first thing we fit in are the critical numbers and point. So the first one is 1, 7. So 1 is somewhere here. Let's assume 7 is, let's call it 7 is somewhere here. So that 1, 7 is somewhere here. So we have here 1, 7. So that's the first critical value. Critical point, I beg your pardon. The second critical point is 3, 3. So let's call this point here 3. And then call here 2, 3. So that 3, 3 is somewhere here. So this is the point 3, 3. With the information we have here of increasing and increasing intervals, we can now sketch the graph. So we have from minus infinity to infinity. So in the first interval, from negative infinity to 1, what happens to the function? The function is increasing. So the graph of the function from that in that interval looks like this to that point. It's an increasing function. Now, in the interval 1, 3, between the interval 1 and 3, the function is what? Decreasing. So the slope of the function looks like this. And in the third interval, 3, infinity, the function is an increasing function. So in the third interval, the function goes up again. It's just a sketch. But this is how, the graph of the function looks like.